What does it mean for something to be a factor of something else? So we're going to talk about 36 specifically. 36 is a nice number because it's got a lot of factors for how big it is. What does it mean to be a factor? It's interesting. We're going to drill into the definition here. And if you know it already, if you've like looked ahead or anything, or you just are good at figuring this stuff out, keep it to yourself for now. I want everybody to be able to hear or think about this, okay, and kind of go through all of the process of kind of wondering and thinking and trying to come up with the answer on their own. But eventually, we'll get to the specific definition that we want. And sometimes, like, it's interesting. This is one of those things where you might have a hard time coming up with a definition, but you could all list factors of 36. Like, somewhere inside, you know what a factor is. But do you know what makes it a factor, what the definition could be, which is what we want to get to. That's going to help us when we're not dealing with numbers and we're dealing with polynomials where it's not as obvious. So somebody give me something that is a factor of 36. Give me a factor of 36. Kieran?
12.
12? I like it. Give me another one.
6.
I like it. 2?
4.
4. See what I mean? There's lots. Somebody else.
3.
3. 9.
13.
Not 13. No, not quite.
18.
18.
1. And 36.
So 1 and 36 are kind of different, but they work for us. Like there's something special about them, but we're going to include them in the list as factors. I think that's the list. What do you notice about the list? They kind of pair up. Was anybody thinking about that when they were trying to come up with them? So 12 goes with 3, 6 and 6, so we don't have to write it twice. 2 and 18, 4 and 9, 1 and 36. So they kind of pair up, right? Those are factors of 36. Somebody give me something that's not a factor of 36. Kieran?
112.
What else? Andrew?
7.
Keep going. Shout them out.
10.
Good. 0. How about pi? How about root 2?
13.
13. How about 8.400132? Like, man, we exhausted the factors of 36. Any other number that you can think of will not be a factor of 36. So now that we have that list, how would you, in your own words, explain what makes something a factor of a number and something not a factor of a number? How would you describe that? It doesn't have to be a technical definition. In your own words.
Something that can be multiplied by something else to get.
What's special about the something? Because I could multiply 72 by a half. Are they factors? So what's special about what you multiply? So she said something that you multiply by something else that gives you 36. It's a good answer. What's special about that something? Can you put that into words? Not quite?
Like whole numbers.
Got to be a whole number. So 72 is a whole number, but a half isn't. Okay? So a whole number that you multiply by another whole number to give you, in this case, 36, but to give you whatever you're looking for. What's another way of saying that? There's a little bit of a nicer way of saying that. A little bit more eloquent. Okay, the numbers will be equal or less than 36. Yeah, good.
A number that 36 can be divided by and just give an integer.
Yeah, a number that 36 could be divided by that results in a whole number. It's a little bit of a nicer way than saying two numbers that are multiplied together. You kind of think about it, well, any number that divides evenly into 36 or into your number. In other words, divide by it and you get a whole number. Does that make sense? Now we're getting closer to a proper definition. Jackson. Oh, yeah, go for it. Now, let's take it one step further. What did we learn about yesterday? What was the title of the lesson? Remainder theorem. How can we relate this to remainder theorem? What's the relationship between something being a factor and the remainder? One person with their hand up. Don't sit there and say, somebody smarter than me will come up with this, I'll just wait for them to do it. No, think. This is important. You got to practice thinking about new things. University is, oh boy, a lot of that kind of thinking. And we don't do enough of it in high school. Okay, hold on to that. What if I divide 36 by 7, long division? What remainder would I get? 7, 14, 21, 28, 35. Remainder of 7? 1. What if I divide by 9? Remainder of
Nothing.
0. So what do you think?
If there's a remainder, then it's not a factor.
If you get a remainder, it's not a factor. So if your remainder is, well, you get a
It wasn't
remainder, but
divided by it.
yeah. So if you get a remainder, it is a factor. If you get a remainder of 0, was that you? Of 0. Remainder of 0 means it divides evenly. It divides perfectly, gives you a whole number, no remainder, no decimal part. So it is a remainder, but it's remainder of 0. So remainder equals 0, then it's a factor. If I divide by 12, I get 3, remainder 0. Divide by 18, I get 2, remainder 0. Divide by 5, I get 7, remainder of 1. So 5's not a factor. Aha! More of a technical mathematics type definition that we can say it's a factor if you divide and the remainder is 0, right? Then it's specific, we can look for something, we can test it. Okay, so that's really important, and that is remainder theorem. The function f at x is divided by x minus 8, the remainder is f at 8. Then factor theorem states, you want to write this part down. Factor theorem states, if f at a is 0, then x minus a is a factor because the remainder is 0. So factor theorem is a special case of remainder theorem. And it's the one that for now we're going to really take advantage of. And I've been telling you this all along, doing long division, doing synthetic division, then briefly introducing remainder theorem as a shorter lesson is all a build up to this. Factor theorem and factoring higher degree polynomials. So you can factor degree 1 would be like a common factor, I guess. You can factor degree 2. You learned that in grade 10. Simple trinomials, complex trinomials, difference of squares, common factors. But what about degree 4, 3, 4, 5, 6, 7? Well, after today, you could do any degree. It would be the same procedure for all of them. It's not just degree 3 that we're looking at. It applies to 3, 4, 5, 6. It just takes longer the higher the degree it is. Okay, and then tomorrow we're going to look at a special case and a slightly different type of factoring where you could use factor theorem, but there's an easier way. And then the next day, same thing. We're just going to look at some special cases, but for the next few days, really the rest of the unit, it's all about practicing factoring and how to factor and that kind of thing. Okay? Before we get there, I left some space here. You can do it on any part of your page if you didn't leave space. It doesn't matter where it goes. What is factoring? So in grade 10, when you learn to factor, you get something like x squared plus 7x plus 12 And if I factor that, what does it look like? This is an easy one. Everybody should have their hand up. Who wants to factor that for me? Evan?
X plus 3 and X plus 4.
So two numbers that add to 7 and multiply to 12. Everything's positive, so it's an easy one. And I write it in brackets. I write it as the product of two things. And when it's polynomials, it's a little bit trickier again. But, back in grade 10, you talk about how it's the opposite of expanding. So it'd be x times x, x times 4, 3 times x, 3 times 4. Like, you would do that expansion or whatever. We're not going back over that right now. But that's the idea, right? But I've split it up into a product of, in this case, two things. And those products are the smallest they can be. It's fully factored because it's the smallest they can be. Back in elementary school, you did something, well, actually, you might not have. I don't know if they always do it. But if you had a teacher who was good at math and interested in math, because not all, unfortunately, elementary teachers are, you might have done prime factorization. Did anybody do that? Do you remember that at all? Prime factorization? Okay, so some of you might have and some of you might not. So it works like this. You'll understand it better now anyway. We're going to start with 36 again. Give me two numbers that multiply to 36. Anybody shout them out?
12 and 3.
12 and 3. 3 is prime, so that branch is done. So two numbers that multiply to 12.
6 and 2.
2 is prime, so that branch is done. Two numbers that multiply to 6.
3 and 2.
3 times 2 times 2 times 3 is 36. 3 times 2 times 2 times 3 is 36. All primes. Somebody give me two different numbers, not 12 and 3, that multiply to 36.
6 times 6.
Neither are prime, so we have to do both. Two numbers that multiply to 6. Not 1 and 6, obviously. That doesn't work. Hopefully you figured that out. So we've already done that. 2 and 3. And same thing. Oh, this time I'll be fancy and do 3 and 2. Ooh. 2 times 3 times 3 times 2 is, look at that, 36. Okay, let's do one more. Two numbers that multiply to 36.
18 and 2.
Prime, so we stop. We got different options here. I'll do 9 and 2, and then 3 and 3. What do you notice about all those lists?
The same numbers.
It's the same numbers. And multiplication has the property that order doesn't matter. 3 times 2 is equal to 2 times 3. You can multiply lots of things in a different order, and you get the same result. Just like down here and back in grade 10, and still now you might think about it and ask about it. X plus 4, could I put the 4 there instead? Yeah, right. Order of the brackets doesn't matter. You remember that from grade 10? Okay, it doesn't matter what order you do it in, because 2 times 3 and 3 times 2 are the same. Same goes here. This is called prime factorization. All numbers have a unique list of prime numbers whose product gives you that number. So if we changed it from 36 to 72, it would be a different list. If we did it for 9, it's 3 times 3. Those are your prime numbers, right? Every single number in the world has a unique list of primes that give you that product together to give you that number. That's not really what we're doing, but it is related, and it's sort of the number way of thinking about what we're doing when we're factoring polynomials, is we are looking for the list. It's going to look more like that, but we're looking for the list of brackets or terms or things that multiply together to give us back the original expression or function that can't be factored or divided further. We don't really call them primes, but it's kind of like that. If you can keep factoring, then you do, until you can't anymore. Okay, does that make sense? So that's what we're aiming for. That's our goal. Any questions? All right, let's try it. This is a algorithm. It is a procedure. It also kind of iterates where we do the same type of procedure over and over and over again. So there is some form that has to be done properly. That's a little bit picky right now. In the next unit, I'm going to relax on that a little bit. But for now, you got to show all the steps that I'm going to show. Okay? And you have to know the steps. So part of what you're doing over the next several days to get ready for the test, because it's going to be a big part of the test, is knowing all the different steps. We are going to take advantage of factor theorem and remainder theorem, in the special case of remainder theorem, factor theorem, to find a factor. Okay? Because I can't just look at it like 36 and I know my times table, so I know 4 goes into 36 and I start with 4. That would be nice, that would be easy. We can't do that with a polynomial like this. Okay? I'm not looking for a common factor, it's not that. I'm not looking for a factor of the coefficients, I'm looking for a factor of the polynomial, which at this point you probably aren't even really sure what that means. But basically what we do is we pick numbers, sub them in, evaluate, and keep picking numbers until we get 0. Because when we get 0, that's a remainder of 0. I've evaluated the function at that number at 10, and I got 0. Now I've found a factor, and that's where I can start actually doing the dividing. If you're not fully following me, don't worry. Once we start doing it, it will make more sense. You're going to do this hundreds of times this semester, so you'll get it. What number do you want to start with? Somebody give me a number. What number do you want to have a guess? What should we try first? 3, bad idea. Let somebody else pick another number. It's not your fault, don't worry. Nobody wants to put up their hand now. Yep. 2, bad idea. What's the easiest number? 1. Why not start with 1? Right? 2 and 3, I have to actually do some math. I gotta punch it into my calculator. If I start with 1, these are big coefficients, so it's a little bit trickier. But if I start with 1, I can maybe do some of the math in my head. I can maybe kind of figure it out. Often you will be able to, and often 1 is a factor. So why not start with the smallest numbers and then build up from there to get to the harder ones? So off to the side, I'm going to write this out. F at 1. Normally I would not write this out because it takes too long. But it's up to you. But you would just do this on your calculator. But for this first one, we're going to write it out so when you look back at your notes later, you can remember that we did it. Otherwise, if you draw a total blank and you're like, where did that number come from? Okay, you want to have it written down at least once. So 1 to the 4th is 1, so 2 times 1 is 2. 1 to the 3 is 1 times 5 is 5. Do you see the pattern here? See where this is going? We're just adding up the coefficients because the 1 doesn't change anything. See why that's easier? So 2 plus 5 minus 29 minus 38 plus 120. Is that going to give me 0? Liam, why not?
I just did the math.
Oh, you did the math. What does it give you?
60.
60, that's what I got too. Anybody else get 60? How do I know by looking at that it's not going to give me 0? Two and 5 and 29 and 38. Do they add up to 120? Like not even close, right? That's 30, that's about 40, so that's about 70. Like that's not even close to 120. How is it going to be 0? Doesn't make any sense. So this is what I'm saying. If you pick 1 and you're just looking at the coefficients, you can kind of rule it out right away and say, that's not going to work. Okay? And sure enough, it was 60. That's not even close to 0. But it's up to you. You can punch it into your calculator if you want. Add it up. That's fine. For now, we are going to get the result of each of them. Negative 1 to the 4th is? Positive 1 times 2 is 2. Negative 1 cubed is? Negative 1 times positive 5 is minus 5. Make sure you're following this because this is important. This is going to save you a lot of time. Little things that save you a lot of time. Negative 1 squared is positive, so that stays negative 29. Negative 1 to the 1. That's going to flip the sign. So negative 1 will flip sometimes, but not others. Do you see that? So you're still just adding up coefficients, and there is still no way that the first 4 coefficients will add up to 120. It doesn't matter how I change them to be negatives, that will never happen. So I still know that negative 1, without doing the actual math, just thinking rationally, negative 1's not going to work. The reason why I do this is because this is a fairly long procedure, and anything we can do to trim it down, to shorten it, is going to be helpful. And as I've said many times already, you're going to do lots of this, so you will practice and get used to some of these little tricks. Okay, it's going to happen whether you like it or not. Anybody do that actual math? What's the result? Who's got their calculator and they've got quick hands?
118.
I didn't get 118. I got 126. It's probably just a typo. And you wouldn't lose marks for that because I'm not marking that. I don't really care. You care if it's 0 or not. That's all you care about. Generally, you're doing this on your calculator, not even writing it down. So if you made a small mistake, it wouldn't matter. Now, if you made a small mistake and it was supposed to be 0 and you got something not 0, that's a problem. Now, where do we go to?
2.
Good idea. Right? Keep it small. Start with the positives. Oh, I didn't actually let you guess this one. I just put it in. Then flip to the negative. So 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 5, negative 5. Keep going back. See what I mean? Long process. Keep going until you find one that's 0. This one's a little bit harder. I'm not sure I would recommend doing it in your head. 2 to the 4 is 16 times 2 is 32. 2 to the 3 is 8 times 5 is 40 plus 40. Two squared is 4 times negative 29. Ooh. It's 116. But this is where you don't want to make a silly mistake there. That could ruin the whole question. 38, negative 38 times 2. 76, I think. Plus 120. Somebody do that on the calculator? Yeah.
272.
That's not what I got.
That's 0.
I got 0. You must got a sign out of place somewhere. I got 0. Okay, we found it. We didn't have to go that far. I will tell you, I don't usually make you do like 10 of those to find your first factor. Your first factor will come up relatively quickly. And I'm going to show you more little techniques throughout this unit and next unit that can speed things up. But if you don't remember them, if you don't practice and you don't remember the little tips and tricks that I give you, it can be very long. Okay, so remember what we did. We talked about how something is a factor if it has a remainder of 0 when you divide, and subbing in 2 gave me 0. Remainder theorem tells us then the remainder is 0. Evaluating it, the function at 2 gives me a remainder of 0, so it's a factor. So this is, you don't have to show any of that. When I learned this in high school, I remember my teacher had this whole table that you had to draw, and you had to write out all these numbers and everything on the side, and like we wrote it out every time. Oh my gosh, what a waste of time. But calculators are so good these days. Just do it on your calculator, right? So this is what we're going to say. F at 2 equals 0. You have to make this statement every time. Therefore, what's a factor? What is my factor?
X minus 2.
Thank you. Very good. X minus 2. X minus a, where a is 2. X minus 2 is a factor. Does that make sense? That's really important. Flipped the sign. It's a linear factor. It doesn't have a coefficient out front. Okay, so it's just x minus 2. Any questions? This is important. It's kind of your first step. Find your first factor. Yep.
If f of 2 didn't work, what would you have done next?
Negative 2.
Okay.
That didn't work. 3, then negative 3. Then 4, then negative 4. Then 5, then negative 5. Then 6, then negative 6. And so on. If none of them work, you've probably made a mistake, and I would go back and check 1 and negative 1 again. Like I would go back and check more carefully. Okay, so now that means f at x will equal x minus 2 times something. How do we find that something?
We divide.
Synthetic division. We can do synthetic, right? Because it's linear. That's the easy one. So we do synthetic division. Over to the side, please do it off to the side. You can do it on scrap paper even. I'm going to show you a trick where you don't even have to do synthetic division. Most of you will, but a couple of you, if you're really good at mental math, you might use a trick. It's a bit faster. But I don't mark your synthetic division. I mark your result. So even if you do it on scrap paper or whatever, that's fine. Write out the coefficients. 2, 5, negative 29, negative 38, 120. Okay, keep going. Uh-oh. Did I do something wrong? 120, I got 0. That's weird. Did I make a mistake? No, of course not. That's your remainder. It's supposed to be there. It has to be 0. That's the whole point. We found a factor. What does it mean to be a factor? The remainder is 0. If you don't get 0 there, there's a problem. If you don't get 0 there, you made a mistake finding your factor, or you made a mistake in your division. It's a nice check, isn't it? You better get 0 there. The remainder is 0. It's a factor. That was on purpose. So that had better be 0. Put that 0 in a box where it belongs. That's your remainder. Yep. So it looks like we're on the right track. It would be a very big coincidence if you made mistakes and it still worked out to be 0. That would be like, wow. You made 2 mistakes that canceled each other out somehow. Okay, so pretty good indicator that you've done stuff right if you get a 0 there. Now I take these coefficients. I know it's x cubed. 2x cubed plus 9x squared minus 11x minus 60. Am I done?
Will you add that 0, the remainder?
You could, but you don't have to. And I would say moving forward, why bother? We don't tend to. Done? Next question. No, we're not done. Have we factored fully? Can't I factor that second bracket? I don't know, maybe I can, maybe I can't. But like, what if I can? Which you can. And generally speaking, when I give you these, at least right now, you're going to be able to keep going. So we keep going, we repeat, we do the same thing. Now, this is a technicality, but it is part of the form that I was talking about before. We have to let g at x equal this thing and look for a factor of that. Okay? And we, just for clarity right now, we do have to give it a new name, a new function name. So we're going to call it g and say g is this thing. Now we're looking for a factor of that. So where do you want to start? We're going to do the same thing we did over there. Where do you want to start?
701.
Bad idea. That was the right idea first time around. Why is 1 a waste of our time now?
You can kind of see the negative 60.
Okay, good point. You can tell by inspection that it's not going to work out, but there's another reason. If 1 didn't work for this, could it work for that? Like, go back to the numbers. If 5 doesn't divide into 36, could it divide into 6? No. That's how multiplication and factors work. So, in fact, anything that we've already done, 1 and negative 1, that didn't give us a factor, we can skip the second time around. If that doesn't make sense, think about it, or just remember that. You're wasting your time. If you tried 1 and 1 in F, they will not work for G. You can trust me. So where do we start? 2. Why not negative 2? Because we already did 2. Well, 2 could be a factor twice, and sometimes it will be. Sometimes you'll get the same factor twice. So we ended at 2. That's where you start at the next one. Because it could be x minus 2 times x minus 2. You could have 2x minus 2 brackets, right? So we start at 2. I'm going to help speed this up a little bit. But we would try 2. It doesn't work. Then I would try negative 2. That doesn't work. Then I would try 3. That doesn't work. Then I would try negative 3. And turns out that does work. Do I have that value? Oh, it's 0, yeah. So G at negative 3 equals 0. Therefore, yep, x plus 3 is a factor. Then I go back to f at x. If it seems weird, once you've done this a few times, it does make sense. It's not random. It's not a mistake. How do I find what goes in the last bracket? Synthetic division again. And what kind of a function is it going to be? Quadratic, right? We started with 4, we took 1 out, we had 3, now we're taking another 1 out, now we have 2, right? It goes down in order like that. So go ahead. Notice that I am dividing into G, not back into the original F. I want the result of dividing into G to get this bracket. I got 2, 3, and negative 20. Remainder of 0. Yes, that means I probably did it right. That's what you're expecting to happen. That had better happen. Put that 0 in a box where it belongs. 2x squared plus 3x minus 20. Now are we done? No, we're still not done. Now we go hunting for another factor. Now we make that equal h at x. No, there's an easier way. What am I going to do now? Graham? Yeah, just factor it like grade 10. Tricky trinomial factoring. You pretty much always end up with a quadratic at the end that then you can just factor. Does that make sense? Equals x minus 2. X plus 3. Again, order doesn't matter. What if you made a mistake with 2 and you didn't get a remainder of 0 and you kept going and you got to negative 3 and you divided that out? You're going to get the same results. They'll be in different order. The only problem with that is if you follow my directions and you don't go back and retry 2, you skip it, it doesn't have any other nice fact. Actually, it does have one more nice factor. So you would eventually, in this case, get another one. But in some cases, you might not. So it's got to be 4 and 5, right? 4 and 5. So 2 and 4 gives me positive 8 minus 5. I think that's right. I don't know how, this is why I posted that factoring preview. Because when we get here, I'm not reteaching this. You're supposed to know how to do it. If you're a little bit rusty, you got to go back and practice. I know I did that fast. Most of the ones we do that are quadratics at the end are going to have a prime number somewhere. So that's how I knew. I don't know if you did this in grade 11. Like, I don't know if your teacher showed you this. But when you have a prime either here or here, you know what these are. And then I'm looking at 20 and I'm like, it's probably not 20 and 1. Probably not even 2 and 10. It could be. I think it's not. I think it's 4 and 5. So it's guess and check. And when it's prime, if you can do the mental math quickly, and once you've practiced a little bit over the next few days, you can do it fairly fast. Any questions? Ready to do 10 more examples? Just kidding, there's 3, I think. All right, let's do it. Step 1, go hunting for a factor, right? We have to guess and check and just find something that's a factor. You can't look at that and figure it out. Sometimes you kind of can, but you're still essentially hunting for a factor. What do we start with? 1. 2 plus 5 is 7, minus 15 is negative 8, minus 45, minus 27. Oh my gosh, that's not 0. Right? Negative 15, negative 45, and negative 27. 2 and 5. They don't cancel out, do they? See how I'm just looking at the coefficients? I got 3 big negative coefficients and 2 small positive coefficients. They do not add to 0. So 1 does not work. If you want to put it into your calculator and do the math that way, if you're more comfortable right now doing it that way, fine. But this is a way of speeding things up. What about negative 1? If I can get my calculator to show up. There we go. Okay, watch for a second. So the 2 is going to stay the same sign because when I put negative 1 in, I raise it to the power 4, and it's going to be the same. So 2. The 5 is going to flip signs because this is going to be negative 1. So minus 5. The 15 will stay the same. The 45 will flip. The negative 27 obviously stays the same. Bam. 0. So negative 1 worked. F at negative 1 equals 0. Therefore, x plus 1 is a factor. First one was a little bit disconnected because I was stopping to think about things. So I'm going to go through this one kind of on my own just so that you can see what the procedure looks like a little bit with a bit more flow to it. Okay. Found my first factor. Come off to the side. Synthetic division. Minus negative 18, so that's going to be negative 27. 0, remainder of 0, put that in a box where it belongs. Again, I would love it to slow down and let you practice that on your own, but you're already supposed to know how to do synthetic division. You're going to get lots of practice when you do this on your own. So to speed up the lesson, I'm going to do some of this work for us. I'm just going to kind of give us the answers so we can move on to the procedure. If you're stuck on synthetic division, if you can't get that right, then the whole thing falls apart, right? So then now you know what you have to go practice. I got to get perfect at synthetic division. Two x cubed plus 3x squared minus 18x minus 27. One didn't work for F, so it won't work for G. -1 worked for F, so we'll try it in G. I'll give you a hint, it doesn't work. What do we try next? Graham? Wrong again. I'm mean, I know I'm horrible. Why can we skip 2? There is a reason we can skip 2. You could do 2 and you would just find it wouldn't work. But there's something about this that tells us we can skip 2. Nope. It is because of the -27. And I'm going to go back up to the last question to think about, to show you something and think about why that makes sense. Take a look at the last number in each of the brackets, -2 and 3 and -5 and 4. What will they multiply up to if I multiply them all together? Do it on your calculator. Somebody do it on the calculator. -2 times +3 times -5 times 4.
120.
It gives you 120. Don't they have to give you the original constant? Right? If we re-expand, like the whole point is these 4 brackets re-expanded gives me back the original f at x. Now don't do that. Don't waste your time. That would be, ugh. That'd be horrible. 2 of them is fine. That's a quadratic. Now you're multiplying by another one. You got a cubic. Now you're multiplying by another one. Oh my gosh. Like that's just too much work. Right? So we don't do it. But getting the first term's not bad. X times 2x times x is 2x to the 4th. And getting the last term's not bad. It's just multiplying the constants. In fact, we already did that. We already did that in the first half of the unit when we talked about pretending to expand to see what our y-intercept is and to see what our leading coefficient is. The y-intercept is the product of your constants in those 4 brackets. Right? Now we're talking about factoring. These are still x-intercepts if I graph this as a function on a graph. Don't forget what we've already done in this unit talking about this stuff. These are still x-intercepts. So that would be your y-intercept, 120, and those have to multiply to that. If they have to multiply to that, then 2 is not going to work because 2 is not a factor of 27. So you can look at that final constant in the original function or in g at x, and it has to be a factor of that to work. Okay? So we can skip 2 and -2 and move on to 3, and it turns out 3 does work. Remainder of 0, put that 0 in a box where it belongs. Beautiful. Got a remainder of 0 again as we expected. We are on the right track. Maybe you're starting to see why we flip over to g at x just to deal with that cubic part, but then what we're really doing is factoring f at x. So we come back and we're always writing out f at x in full because that's what we want to be factored fully at the end. Okay, we're down to our quadratic. 2 is a prime again, so it's got to be 2x and x. And then the other 2 multiplied to 9, don't you think it's going to be 3 and 3? And in fact, everything's positive in this case. 6x and 3x is 9x, so we got it. Any questions? All right. It's a little bit harder to see, but 1 doesn't work. 13 and 8, the negatives, gives you 21. 6 and 17 and 6 is not 21. So the negatives and positives don't cancel, so 1 doesn't work. But it turns out, once again, -1 does work. So 6 plus 13, I flip the sign because putting -1 in is going to flip it, minus 8 minus 17 plus 6. If I type that in right, should give me 0. If you think you can do this, don't just copy me, go ahead. Are you with me now? I'm going to show you something a little bit new. So I got to my g at x part. I try -1 again. Doesn't work. But 2 does. Okay, once you get caught up to where I am, have this written down. I want you to watch. Okay, so just put your pencil down and watch. I show this every year, and usually there's a few students who will try it. I know for a fact that there are schools that only teach this method that I'm about to show you. So it's doable. Obviously, their students can do it. But it does require a little bit more focus. It requires a bit more practice. Like, you got to try it a few times on your own. It might seem a little bit weird at first. So if it's not working out, or if you don't even want to try it because you're already feeling overwhelmed, synthetic division is fine. This is only a little bit faster. Synthetic division is fine. You can do that all throughout. It's the way that I do it because I've gotten used to it. Okay, so it is a little bit faster, and it is doable. Like every one of you could do it with some practice. So it's up to you, but I'm going to show you. When I take x minus 2 and multiply it by whatever quadratic that's going to end up being, I've got to get back g, right? So what's that first term have to be? X times what is going to give me 6x cubed?
6x squared.
6x squared. Doesn't that first term have to be 6x squared? Now the next term is the hard one. Now I'm looking for negative 19x squared. And you got to get used to kind of going back and forth between the two functions. I'm looking for negative 19. And it's x squared. What does negative 2 times 6 give me?
Negative 18.
Huh?
Negative 18.
Not 18.
Or 12.
Thank you. Negative 12 x squared, right? X times what added to this x squared term will give me negative 19. In other words, what do I need that middle term to be? So when it goes together with the negative 12 that I already have for x squared, because this is going to be an x term. In the middle here is going to be x. X times x gives me another x squared. Those are the only two x squared terms. So what does that have to be? So when I put it with negative 12, I get negative 19. Negative 7, doesn't it? If this is negative 7, I get negative 12x squared from these two that I already know, and then I get negative 7x squared to give me back the negative 19x squared. So there's no extra writing on the side, you just do this in your head. I'll put that back in a second. Now I'm looking for 11x. So I've got negative 2 times negative 7, which is positive 14. But I need 11. So don't I want to subtract 3? $12x squared negative 7x squared if you're good at mental math and you like a bit of a challenge, try it. Give it a try. Maybe not today, maybe later, but like, you know, some of you, I think it's reasonable, should give it a try. But if you're feeling like, man, I didn't really follow that, it's fine. Or ask about it later, I'll go over it more slowly. And we didn't have to wait till here. You could do it up here too. You could do it from the very beginning. It'll always work. There's only ever going to be two pairs of things you multiply together to give you each of these. And I know they're in descending order. I know the first one is x squared, then it's x, then it's a constant. Like I'm using the things that I know, taking advantage of them, and just figuring out the coefficients. But it's up to you. Okay, any questions? I always get a couple of students who come back and they're like, can you show me that trick again? I just want to see it a couple more times. And then they take it on and they do it. Okay, so keep it in mind, it's doable. At any rate, whether you do it that way or synthetic division, we've got our quadratic. I think it's probably 2 and 3. So that's going to be 3. So I get 9x minus 2x. Oh, negative 9. Sorry, I got my signs backwards. It's negative 7x. Negative 9x plus 2x is negative 7x. Any questions? Okay, we got one more to try. I'm going to suggest you do this one on your own. If you're watching at home, pause the video and give it a try yourself. And then you can take a look at the answer, and you can jump to the end and take a look at the answer, because I am going to still explain what I'm doing as I go. And then if you get the right answer, fantastic. Consider all the steps again. You have to go hunting for the first factor, start subbing in numbers, figure out one number that gives you a result of 0. Okay, and then do the division. I think I'm going to try it both ways. I'm going to try that new little trick, but then also show the synthetic division. And if you try it yourself and you get to the end, but then you see that you made a mistake, you can rewind the video and go back and watch it from the beginning to find your mistake. But hopefully at this point you're getting the general idea of how all of this procedure works. All right, so give it a try yourself. All right, so what I'm going to do is I'm going to pull up my calculator and I'm going to try +1. And again, +1 is just adding the coefficients. +32 minus 16 minus 16. Now that gives me 0, but then I got those two other positives. So altogether, this is not going to give me 0. Again, I can check that by inspection. I don't actually have to pull out my calculator. But sometimes that takes a little bit of getting used to. Now I'm going to check -1. So 9 will stay the same. The 36 will flip. 32 will stay the same. 16 will flip. Close to 0, but not 5. So that one you might kind of do by inspection and say, oh, it looks like it could be 0. And if you actually do the adding in your head, then you would get that it's not. But it's close enough that it may not be as clear to tell. So now I will do +2. That's 9 times 16 plus 36 times 8. So again, anything you can do to speed it up. Doing the exponents in my head, because I know the powers of 2 well, that is worthwhile. This one, again, because of the fact that those first 3 terms are all positive, it's not going to work out. I can even tell that. And in fact, after having done enough of these, I can kind of tell that it's going to be a negative for sure, because those positives, I got to flip one of them. I don't have enough negatives in there. So it is going to be negative something, even if I had to go to -3, although that wouldn't work because of the 16. If I had to go to 4, +4 is not going to work because all of those are going to be too big. So it's going to be some kind of negative factor. And turns out -2 does work. So 9 times 16 minus 36 times 8 plus 32 times 4 plus 16, or that should be plus 32 minus 16. If I type that incorrectly, I get 0. So we've got F at -2. So I know this is cubic, and I know that the first term is going to be 9x cubed. So I do x times 9x cubed, gives me 9x to the 4th. Now is where I have to think a little bit harder and recognize that this times this will give me an x cubed term, and this times this, because whatever that is going to be x squared. Right, the next term in order will be an x squared term. So this one and this one have to give me the x cubed. So 2 times 9 gives me 18, and I need 18 more to get to 36. So this is going to be positive 18x squared, so that 2 times 9 is 18, 1 times 18 is 18, 18 plus 18 is 36. It's only ever 2. In this setup, that's how it works. Okay. Next, I'm going for the x squared term, so I'm trying to get 32. So 2 times 18 is 36. I'm too high. I've got to go down 4. So 1x times negative 4x will give me negative 4x squared. And those are my two x squared terms. 2 times 18 is 36. 1 times negative 4 is negative 4. 36 minus 4 is 32. And then the last one, 2 times negative 4 is negative 8x. And then I need another negative 8x, whoops, to get to negative 16. So this is going to be minus 8, so that I get x times negative 8 gives me negative 8x, and negative 8x is negative 16. And often people will ask, well, couldn't I just look at the last one? And 2 times that gives me the constant, absolutely. But I kind of like to do the x's, do it that way, and then use that as my check. So if I get to that point and those do give me the constant, then I can be pretty sure that I did the whole thing right. I think if you made a mistake throughout, you might still be able to find answers, but the last term wouldn't work out. Okay, so the fact that it worked out for both those last two, that's telling me that, or both these last two maybe is what you kind of think of it as, we've done it correctly. If you don't like that way, if you've already practiced synthetic enough that you're really comfortable with it and you just want to stick with it, that is totally fine. As I've said, this method doesn't save you a lot of time. So 9 times 2 is 18. Subtract. Times 2 is negative 36. Sorry, that's not supposed to be negative. That's positive. So 36, positive 36, 32 minus 36 is negative 4. Negative 8. So now I'm adding 8. And negative 16, perfect. Got my... And that is a little bit of an easier check than the other system as well, where you get that 0 and you can be really confident that you're on the right track. So again, 9, 18, negative 4, negative 8, we got the same results. It's up to you which one you like best. So negative 2 worked for this one, again, because we did try 1 and negative 1 and 2, and they didn't work for F. They won't work for G, but negative 2 could work again, and in fact, in this case, it does. So let's just do it. Okay, so trying negative 2, this looks like 9 times negative 8 plus 18 times 4. Negative 4 times negative 2 is plus 8 minus 8, 0. All right. Okay, so now I'm looking at G, and again, x times whatever comes first has to give me the 9x squared, so that's going to be 9x squared, has to give me the 9x cubed, sorry. So 9x squared times x is 9x cubed. Now, this is interesting. 2 times 9x squared is 18x squared. I already have the middle term. So what do I want to multiply this by? It's actually 0. Okay, so I've got 18x squared, and 0x squared gives me 18x squared. Do you have to write that in there? No, but for now, I think it's a good idea. It's kind of like your ghost term, your placeholder term. Okay, then I get 2 times 0, so that's 0, but I'm looking for negative 4x. So I need to do x times negative 4 to give me negative 4x. That gives me the middle term, and then my check is 2 times negative 4 is negative 8. So everything looks good. And it turns out that is a difference of squares when I take out that middle term. So when I do the final factor, I get x plus 2 all squared times 3x plus 2 and 3x minus 2. A little bit of a different way of it coming out. If I did the synthetic division, 9, 18, -4, -8. Bring down the 9, times 2 is 18. Take a look at that, you still get your 0, of course, times 0. -4 minus 0 is still -4. -8, 0, put it in a box where it belongs, and we get the same answer. All right, so again, first time you see it, maybe it feels like a lot, but you can really break it down into those steps. You got to remember that first step, it's key. Go hunting for a factor, be efficient. As you're working through it, think about all the little things that you can do to speed things up. Are there values that you can skip? Like in this case, you could skip 3 and -3. Are there things about the coefficients that are telling you something? It's a little bit more advanced, but like I said, in this case, looking at the 3 in the original function in f, the 3 positive coefficients are so big that the 2 negative ones are not ever going to catch up unless I can flip those signs. So the factors that go in there are going to have to be negative. Okay? So there are little things that hopefully you'll continue to think about and pick up along the way, and if you can do that, then you know that's going to help you speed things up, and that's going to be a big part of it, because otherwise it can be a lengthy process. Okay, and that's it. That's factoring higher degree polynomials.